So this is 1988, number 28. And so the best way is just to know what this graph looks like, and that would be the fastest way. So if you know what this graph looks like, you would say it's shifted right 3 in its absolute value, so it's going to look like that. And you're integrating from 1 to 4. So conceptually, you're finding the net area from 1 to 4. So the net area would be the area of that plus the area of that. So you could do this pretty easily just using geometry. So what we have here, the first triangle is 1/2, the base is 2, and the height is 2, plus, and then you have the second triangle, it's 1/2, the height is 1, and the base is 1. So you end up with 2 plus 1/2, which is 2 and 1/2, which is 5/2. Okay, that's the quick way. That's probably the easiest way, but there is another way. I want to show you this because if this function was not easy to graph like that and look at that way, you would have to do it this way. So you have to understand how absolute values work. Absolute value of x minus 3 can be written as a piecewise function. So here's my claim. Whenever this part, x minus 3, is positive, that occurs when x is greater than 3. So I'm going to state when x is greater than, actually equal to 3, because if it equals 3, I'll get a 0, and the same thing. What does the absolute value do to a number that's positive or 0? It does nothing. So the function is going to equal x minus 3 if it's positive or 0. It's not going to change. But what happens when x minus 3 is negative? Or in other words, it happens when x is less than 3. The absolute value takes a negative number, makes it positive by taking the opposite of it. So I'm going to take the opposite of x minus 3 whenever it's negative, and that's when x is less than 3. So those are my two functions, and it changes at 3. So I'm going to change this integral, and I'm going to go from 1 to 3, and then I'm going to go from 3 to 4, because I'm going 1 to 4. So I can break it up into two parts. Why do I change at 3? Because at 3, the function changes from x minus 3 to the opposite of x minus 3. So this becomes, so from 1 to 3, it's just x minus, no. From 1 to 3, it's minus x minus 3. So from 1 to 3, that's in this range. So we use the opposite. So the opposite makes this negative positive. And then from 3 to 4, I use the top one because that's when x is greater than 3. So I just use x minus 3. And then I'm not going to do all the work here. You can distribute this negative. You get minus x plus 3. And then x minus 3. Then you take the antiderivative and plug in numbers. So it would be minus x squared over 2 plus 3x from 1 to 3 plus x squared over 2 minus 3x from 3 to 4. And you plug in the numbers, subtract, and you should get 5/2 also. That was a lot more work. Way better just to draw triangles, find areas. But like I said, sometimes if it's not an easy graph, you're going to have to do it the way I just showed you. Okay, so that's it for that problem.